Okay, a quick review of polar and Cartesian coordinates. So, polar coordinates gives information in terms of distance and direction. So you'd have a center point and you'd be going out in circles around that. That would give you the distance. Somewhere out along one of those circles tells you how far away you are from the center. Then you have direction. Okay. And usually would do something like every 30 degrees. So 0 degrees along the positive x, 30 degrees, 60 degrees, 90 degrees, and so on, going around counterclockwise. Cartesian coordinates gives it in terms of x and y. So you have your center point, and then you're tracking along two lines, and you'll go some distance out along each one. So here we could locate a point at 3, 2, vice versa. If we were trying to do something similar over here, we'd maybe look at 3 units along 30 degrees. They're not the same value, but it's a way of indicating where a point would be in a two-dimensional space. You can do it with distance and direction. So 5 miles due east as the crow flies. Or you can do it as go 3 blocks to the west and then 2 blocks to the north, or something similar. You can, of course, transfer in between the two. You can turn a Cartesian coordinate value into a polar coordinate value, and that's actually the thing we really want to review right now. So let's say you have polar and you want Cartesian. You'd actually find the x component as the distance part. So this part does it as r and theta, this one does it as x and y. X would be r times cosine of theta, and y would be equal to r times sine of theta. Now vice versa. What if you have Cartesian and you want polar? Well, r is the distance. If you think about this as a right triangle, come out along one side, go along the other, hypotenuse through the middle. It's basically the distance formula, the Pythagorean theorem. R would be the square root of x squared plus y squared. And the angle would be the inverse tangent of the y component over the x. But I want to make a note there. Your calculator only understands how to do inverse tangents between minus 90 degrees and positive 90 degrees. If it's outside of that, if the actual angle is 120 degrees going around, your calculator is happily going to tell you that the answer is negative 60 degrees. Well, your calculator is wrong. Your calculator is not paying attention to positive and negative signs on these x's and y's correctly. You need to recognize which quadrant, normally we'd label it quadrant 1, quadrant 2, quadrant 3, quadrant 4. You need to recognize which quadrant it should be in, and if it's giving you quadrant 4 when it should be 2, you need to add 180 degrees. So, possible you need to do plus 180, or plus pi if you're doing it in radians. Okay. It will only ever get quadrant 1 and quadrant 4 correctly on its own. You have to add 180 if it's supposed to be in quadrant 2 or quadrant 3. So keep that in mind. Alright, why do we care about this? Because we're about to talk about vectors, and there are two different ways of labeling vectors. You can either label a vector in terms of its components, which we'll need to talk about unit vectors for, or you can label it in terms of a magnitude and a direction. So we'll be getting to that shortly.